Hey yo hey! Welcome to another super amazing video. I was actually waiting for you. And now that you are here, we can continue our journey towards mastering the concept of the volume of right circular cylinders. Now, in the previous video, we discovered the volume and capacity of right circular cylinders. And then we applied what we learned to dig a well in the rural area. Now, in this video, there are some more challenges that you will have to face and ace. So, ready to play the savior again? Let's roll. Something off topic, before diving deep into the sea, a diver must be prepared with the necessary equipments and gears, right? Quite similarly, before diving right into solving problems, we must arm ourselves with the necessary formulae that may come in handy. So, we know that for a right circular cylinder, the volume and the capacity are calculated using the same formula, that is pi r squared h. Here, r is the radius of the base or the radius of the cylinder and h is the height and in some instances even the depth of the cylinder. Now, we may come across such questions that may ask us about the surface areas as well. No worries though, we already know that for a right circular cylinder, the curved surface area is calculated using 2 pi r h and its total surface area is calculated using 2 pi r into r plus h. So, now that we have recapitulated all the formulae that may come in handy, let us see where all we can use them. We'll begin with a simple question. Say this one. The question says that it costs rupees 2200 to paint the outer curved surface of a cylindrical vessel 10 meters deep. Now, the cost of painting is at the rate of rupees 20 per square meter. And we have to find the following. Pretty simple and straightforward. There's the cylindrical vessel whose outer curved surface is painted. Now, the total cost of painting and the rate per square meter are available. All we have to do is find the outer curved surface area of the cylindrical vessel, the radius of its base, and also the capacity of the vessel. So, now that you have understood the question, what do you think should be our approach for this one? Well, the question asks us to find the outer curved surface area of the vessel, right? Now, for the outer curved surface area, the formula is 2 pi r h. The question gives us the value of h as 10 meters. But what about r? We would need the value of the radius of the cylinder, right? But that's not available here. In fact, it is one of the requirements. So, without r, how do we find the outer curved surface area of this vessel? Always let the question guide you. Let us see what's given here. We know the cost and the rate of painting the complete outer curved surface. What do you think would happen when we divide the cost of doing something by the rate? We would get the quantity, right? It's just the unitary method. So, if we divide the cost of painting the complete outer curved surface by the rate of painting, we would of course get the area of the outer curved surface of this vessel. Once the outer curved surface area is known, we just have to substitute the value in this formula and we will get the radius. With the radius being known, finding the capacity of the cylindrical vessel would be a cakewalk. So, now that we have mentally charted our course to the solution, let's get to the calculations right away. Now, the cost of painting the complete outer curved surface is equal to rupees 2200 and the rate of painting is equal to rupees 20 per square meter. So, on dividing the cost by the rate, we get the outer curved surface area is equal to 110 square meters. Now, on substituting this value in the formula, we get 110 square meters is equal to 2 pi r h. On using h is equal to 10 meters and simplifying, we finally get the value of r, which is equal to 1.75 meters. So, two of the requirements are met. For the third one, we know that the capacity of this cylindrical vessel can be easily calculated using the formula pi r squared h. Here, r is 1.75 meters and h is 10 meters. So, on substituting these values in the formula and then simplifying, we get 96.25 cubic meters. So basically, the capacity of this vessel is 96.25 cubic meters. Now, even though this isn't wrong, it is always preferable to express capacity of a container or a vessel using units like millimeters, liters, and even kiloliters. Now, we know that 1 cubic meter is the same as 1000 liters, right? So basically, the capacity of this vessel is 96.25 into 1000 liters. But what's 1000 liters? A kiloliter, right? So finally, the capacity of this cylindrical vessel is actually 96.25 kiloliters. Here's a fun fact for you. How many liters do you think are there in a megaliter? And how many are there in a gigaliter? Well, the trick lies in the prefix. In general, kilo refers to 10 to the power 3. Mega refers to 10 to the power 6. And giga refers to 10 to the power 9. So basically, a megaliter is the same as 10 to the power 6 liters. And a gigaliter is nothing but 10 to the power 9 liters. That was a pretty interesting question, wasn't it? Let us now try our hands on something a little more challenging. Say this one. It says that a lead pencil consists of a cylinder of wood with a solid cylinder of graphite filled in the interior. Now, the diameter of the pencil is 7 millimeters and the diameter of the graphite is 1 millimeter. The length of the pencil is given as 14 centimeters and we have to find the volume of the wood as well as the volume of the graphite. Needs some active visualization, doesn't it? Let's discuss. So the question talks about a lead pencil, right? How do you imagine it to look like? Something like this or like this? Well, the question gives the hint. It talks about a cylinder of wood filled with a solid cylinder of graphite. So basically, this is the pencil we are going with. Now, the diameter of the pencil is given as 7 millimeters and that of the graphite is 1 millimeter. Also, the length of the pencil is 14 centimeters. All we have to do is find the volume of the wood and also the volume of the graphite inside. So, what's your approach going to be for this one? How would you find the volume of the wood and that of the graphite? Well, finding the volume of the graphite is easy peasy. We know the diameter, which implies that we know the radius, and the height is already given. So, on using these values in the formula pi r squared h, we can easily find the volume of the solid cylinder of graphite. But how do we find the volume of the wood? Isn't it intuitive? We just find the volume of the complete pencil and then subtract the volume of the graphite. Makes sense, right? And finding the volume of the complete pencil isn't a challenge at all. The diameter is given, so the radius can be found by halving the diameter. And the height is of course known. See, the question is practically solved again. Let's just get over with the calculations in a jiffy. The diameter of the solid cylinder of graphite is given as 1 millimeter. So, its radius, say small r, would be 0.5 millimeters. And the height of this cylinder would be the same as the length of the pencil, that is 14 centimeters. Since the units are different here, we can either convert the radius 0.5 millimeters to centimeters or we can convert the height 14 centimeters to millimeters. Here, I am choosing to convert the radius 0.5 millimeters to 0.05 centimeters. So now, substituting these values in the formula pi small r squared h, we get 22 by 7 into 0.05 into 0.05 into 14 cubic centimeters. The common factors obviously get divided and we get 0.11 cubic centimeters. So basically, the volume of graphite in this pencil is 0.11 cubic centimeters. Now, for the volume of the pencil, the diameter is given as 7 millimeters, so its radius, say capital R, would just be 3.5 millimeters. And the height of the pencil is 14 centimeters. Here again, we convert the radius 3.5 millimeters to 0.35 centimeters. So now, on substituting these values in the formula pi capital R squared h, we get 22 by 7 into 0.35 into 0.35 into 14 cubic centimeters. On simplification, this results in 5.39 cubic centimeters. So, now that the volume of the pencil and that of the graphite are known, we just subtract the latter from the former to get the volume of the wood, which turns out to be 5.28 cubic centimeters. So, summarizing, the volume of the wood is 5.28 cubic centimeters and the volume of the graphite inside is 0.11 cubic centimeters. Hey, we solved two interesting problems in under 10 minutes. You are doing absolutely amazing. But to be a true master of the concept, you know that constant practice is a must. So, if it pleases you, watch this video once again for a greater understanding and then go to the quiz section in the app to solve the problems. I'll be seeing you super soon with another amazing video. Till then, keep practicing and keep learning.